Hi everyone, let's start with the next problem. In the last lecture, we have seen about the sliding window and a basic example. Now we shall continue another example on the same concept. So this example is called as the smallest subarray with the given sum. Let's read the problem. The problem is given an array of positive numbers and a positive number s. Find the length of smallest contiguous subarray whose sum is greater than or equal to s and return 0 if no such subarray exists. So what they basically want us to do is they have given us an array and a required sum s. So we have to find the length of smallest subarray whose sum is greater than or equal to the given sum or the given value s. Okay. So let us see an example. So this is the example one is this is the given array, it is 2 1 5 2 3 2, and we have to find one such subarray whose sum is equal to 7 or greater than 7. So its length, actually you have to find its length. So after solving this, what we find is that there is the smallest subarray of length 5 comma 2, that is of length 2, whose addition will give us greater than or equal to s, that is greater than or equal to 7, that is 5 plus 2 is 7, and the length of that array is 2, so the answer is 2. Now similarly, example second is 3 4 1 and s is equal to 8. So here we have two subarrays of length 3 whose sum is greater than or equal to 8, that is 4 plus 3 7 plus 1 is 8, 6 plus 1 7 plus 1 is 8. Now since we are solving the sliding window approach problems, it might be easy for you to guess that sliding window can be used, but in a situation where you don't know what to be used, we can take the hint that they have asked us something to do with the contiguous subarray, right? So in the last lecture we have seen that whenever the pattern is like doing something with the subarray or contiguous subarray, there is a high probability that we can use the sliding window approach, right? So now we shall try how we can use sliding window approach in this scenario. The brute force solution will be to start from each element and to go on adding elements until you get the value greater than or equal to 7 or greater than or equal to the value required sum. Okay, and the time complexity will be of n square, right? Because for each element, in worst case we'll scan all the remaining elements, so it is upper bounded by n square, so we'll require two loops, right? Now let us see some observations for this problem. The observation is that since the question is about contiguous subarray, sliding window approach can be used. Yes, right, as I have said. Also, one thing to note that here the size of sliding window is not specified, right? Yes, because in the last lecture we have seen when we have for the sliding window, they have given us the size of the window, but here the window is dynamic. So this is another variation in the sliding window approach. Okay, so now let's see what the brute force approach can be. So just we can simulate the problem, that is for each element we can add all the elements after it till the sum is greater than or equal to the required value, and of all the arrays we have found so far, we can count the least length and we can return it, so it can be upper bounded by n square. Now what can be the optimized solution? I request you to pause the video and think of some solution for at least 2 or 3 minutes. Now I will move to the optimized solution. Now the optimized solution. Okay, now what is the optimized solution? Now here what we are going to do, first we want to know two things, that is first one is that is the size of the window, it is not fixed, right? So we don't know, but we have just one guess, that is the sliding window approach can be used. So what at first we can do is we can just go on adding elements until we find one such array whose sum is greater than or equal to the required value, right? So that will be our initial sliding window. So that's the first point. First we will add up the elements from the beginning of the array until their sums become greater than or equal to s. Okay, so these elements will constitute our sliding window, and this window will be the length of sliding window found so far. Yes, because initially we want some window, right, on whom we can perform the operation. In the previous lecture the size of the sliding window was given, so we were sure at least till where we can run the loop, right? We are having that constituents of two loops, right, till where we can run the loop, but here the size of the window is not specified, so we should create our initial own sliding window. I hope you are getting what I'm trying to say here. Since the size of the window is not specified, we want to create our own sliding window, right? So now what we shall do is initially we shall go on adding the elements and increase and make up our window until we have the window such that the sum of all its elements will be greater than the required value. Now what we'll do is, now we shall remove the elements from the sliding window until we get sum that less than the required value. Why? Because we intend to find the smallest window, and this shrinking will happen in two steps, right? So what we'll do, we shall check if the current window length is smallest so far, and if so we shall remember its length, right? And we shall subtract the first element from the window, that is like the previous pattern we have seen. We shall subtract the first element from the window and from the running sum and string the sliding window. Once we get the sliding window less than s, we shall again add the elements until we get the required sum. So and we'll check if now the new window which is formed, if it is less or no. So basically what we are doing this whole problem in two steps. In first step we are going on adding the windows until we get uh, the window whose sum is greater than or equal to the required value, right? Now once we get that thing, what we are doing, we are saving this size of the window. This is the second. So I will write for you in short here. I'll write for you in short. So the first thing to do is what we are doing. First add elements. We are doing this till we get sum is greater than or equal to s. Second, now go on removing elements. Go on removing elements until we get value less than or equal to s. Now what we'll do for the first one, this will give us the initial window size, right? This will give us the initial window size. Now once we have got the initial window size, now to get the next window size, that is to get the next window size, we must first remove the elements from our current window. What we must do, remove the elements from current window. But how much to remove? Only that much, such that the sum will be less than or equal to s. That is, we'll go on removing the elements, right? We shall go on removing the elements. Now once we have removed only those many elements where the sum is less than or equal to x, then again we shall go to step 1. Again go to step 1. What we are doing, we are adding the elements such that we shall go on adding the further elements such that our sum will become greater than or equal to s, and this will become our new window size. And finally what we do, finally we compare the minimum of 2, right? So that is basically in short what we are going to do. Let us see the visual representation that will make the things more clear. Okay, so see, suppose our array given is this and the required sum is 7. Now currently my window sum is 0 and my minimum length is, suppose I am taking it as infinity because I want to find the minimum. My window start is also same, my window end is also same. Now I add this element. What I am doing, now I add this element into the window, that is the element number 2. Now once I add element number 2, my window sum becomes 2 and my window end also. Now I am window end is 0, window start is, still my minimum length is 0. Why minimum length is infinity? Sorry, because still I have not reached my required sum. Now again I go on adding the next element, still now sum becomes 3. Then I go on adding the next element, now my sum becomes 8. Now here my sum is greater than or equal to 7, right? 8 is greater than or equal to 7. So this will become my initial window size. This will be my initial window. So this will be my initial window here. Now initial window size will become 3 and my window currently holds element 2, 1 and 5. Now since the window sum is greater than or equal to 7, now we shall go on shrinking the sliding window. Now how much to shrink? We can go on shrinking until we remove all elements. No, but we should shrink only that much until our sum of the window become less than the required. Now I shrink the window, so I remove the first element, so my sum becomes 6. Now here my it is less than or equal to 7, right? Now here my sum is less than or equal to 7, so it is easy that I have removed only that element till where I get the sum less than or equal to my required value. Now again I go on adding the elements since my value has gone below the required value. Now I go on adding the element, again the sum becomes 8. Now this is my new length 3, but since both are same, my length does not change. Now again I go to the second step, that is again since I have got my new length, again I go on reducing the window size. Now since I go on reducing the window size here, how much I should reduce, only that much until I get the value less than or equal less than 7. Now since I reduce the value, I got my sum as 7, which is greater than or equal to 7, and here I got my new length, that is my new length here is 2, and so this will be my minimum length for now. Here window sum still is greater than or equal to 7, and so again we shall shrink the window, but we got new length here. See, this is this step what I'm saying. See, when we in each step we shall do the following things: check if the current window length is smallest so far, and if so we shall remember its length, right? And also we shall remove the first element from the window from the running sum and shrink the sliding window. So we are going to do two things here actually. So that is go on removing the elements, and I guess I forgot to add here one thing. Go on removing the elements and check for this, check for minimum length. Alright, so this is here. Go on removing the elements and check for minimum length. So as you're going to shrink the window, at the same time you should check that even after removing the window, if I am getting the sum which is less than or which is greater than or equal to my required value, so that window length will be also minimum, right? So the next value here I got, see here 5 and 2. Here my required sum is also satisfied, and also the window length has reduced, so the value is 2. Now again, since the condition is not yet broken, that is I have not yet removed those elements which will give the sum less than the required value, I am going to remove another element. So right now I remove 5, now I am at 2. Now since I have satisfied the condition where my required sum is less than the my window sum is less than the required sum, so I'm go on adding the elements. So I shall add 3, still it is less, then I shall add 2. So finally what I do is I get the sum, but the window length is 3, which is more than my minimum length, so I don't update it. So finally my minimum length is 2. So in this way we will solve this problem. So basically I will recap what we are going to do. First we are going to add the elements until we get the required sum, and we shall save this as our initial window length. Now afterwards we are going to shrink the window length. While shrinking, what we are going to do is we are going to remove the elements one by one until we get the window sum less than the required sum, and while doing so we are also going to check that if from the remaining window length if we are able to generate the required sum, and if that length of window and that window length is minimum, so we shall update it, right? And finally we shall go on doing this procedure till the end. So in this way we shall solve this problem. Now to solve, now what you have to do next is you have to go to this link. I shall put this link in the description, and you have to solve this problem. After solving this problem you shall come back and see the solution. So I want you to pause the video and go and solve this problem. I hope with this algorithm you will be able to solve this problem. Only one thing I have not shown here is how you can calculate the window size at runtime, because while shrinking you need to check the window size, right? So that is pretty much easy. I want you to apply your own brains and you will get the answer. It's simple maths. Now I shall move on to the solution. So the solution is very much simple. So first I am initializing my length to the maximum, that will be my final answer. So my window start will be like at 0, that is the initial position, and my window sum will be also 0 for start. So at first what I'm going to do is I'm going to add all the elements until my window sum becomes greater than or equal to s, right? So I won't enter in this loop until my window sum will be greater than or equal to required value. So I go on adding the elements. Now once I've added all the elements, what I'm going to do is I shall go on shrinking. Here I come to the shrinking phase. Now what I am going to do is during the shrinking phase I shall calculate the length here. Now how I am calculating the length, my previous length and my current length will be the difference between my starting position and my ending position of the window. The starting position will be given by the window start and ending position will be notified by I. So I minus window start plus 1 will give the total length of the window, right? So I shall take the minimum of 2, and finally I shall remove the element from the start of the window and I shall increment my window start. So this loop I shall go on carrying on, and finally finally I shall return the length if it is minimum, else if it is infinity, that is no such length has found, then I shall return 0. Why 0? Because that was the thing which they had asked in the question. So I hope you have understood this problem. This was a bit trickier problem than the previous one. We shall solve another problem in the next upcoming video that will be more hard than the previous. So on we shall go on increasing the complexity. So after solving few problems you would get a strong hold on the sliding window pattern. I hope you like this video. Do like this video, do subscribe to my channel if you are new, and do comment if you have any doubts or if you like the video. Thank you.